It's a pleasure to be here today. Thank you, Bajesh, for hosting this conference with all your counterparts and help there. It's going well, and I really appreciate everybody in attendance today. It looks like a varied and wide crowd, so it's really exciting to give information on soil health from the NRCS perspective today. So today I'm going to talk about recognizing soil health and focusing on regenerating soil structure and the soil ecosystem. My background is with the NRCS as a range management specialist. I started my career in New Mexico working on the Eastern Navajo Indian Reservation. And I went to Chadron State College for my 4-year degree there and got an environmental biology degree and worked with Dr. Chuck Butterfield there to learn a lot about range and ecosystem functions. And, you know, I came from central Nebraska. I grew up north of Kearney in a 23-inch rainfall. And when I went out to Chadron, I was really impressed with how dry it was. And then I moved to New Mexico, and then I knew what dry was. We lived in a high cold desert, and we started off stocking rates out there, 200 acres per cow-calf pair. And those cattle honestly had to eat on the run, because if they didn't, they weren't gonna make it back to get a drink in time. So rangeland management out there taught me a lot about soil and the factors of soil that influence productivity and how much the soil health principles really do matter in the productiveness of soil. So today I'm gonna talk about those things here in regards to cropping systems, but realizing that we're working with an ecosystem. Let me see if I can get my slides to advance. I like to start off with this picture, a set of pictures, because in recent times we have really seen some extreme weather events. You know, just in the last couple months even, we've gone into a severe drought. We've seen some really high highs at strange times of the year, 60-degree weather in January. And we've seen some extreme low temperatures, minus 32 degrees in Lincoln a couple weeks ago. That's some extreme weather events. And we've seen some really big rain events. Crops in eastern Nebraska flooding out on the tops of hills. I worked for 4 years in Thayer County and got to see a lot of that. In 2015, we received 15 inches of rain in one night. And 40 years of erosion was accomplished in 6 hours, one farmer said. I took these pictures below, the no cover crop versus cover crop of a waterway, and that waterway on the right had received that 15 inches of rain and actually accumulated a little soil rather than its neighbor had a 20-foot wide, 20-foot deep gully running up his waterway. And just that little bit of cover crop really mattered to that producer there in that very extreme event. But today I'm going to talk a lot about normal events, normal situations, and how it matters. And right here we can see a picture of another hilltop that's droughted out. Not only did we flood out that year, you know, because of the soil functions, that soil couldn't grow that crop successfully on a rain-fed system, and it saw some drought stress. You know, the soil was cracked and bare and really high temperatures, just like Paul talked about. In another crop field in 2017, I took this picture. This was the best yielding corn crop that producer had grown in the whole time he had managed that farm. And it was supposed to be a big failure because the cereal rye got too big and he had to plant that corn green and then terminate that rye cover crop with a herbicide, and he was really worried. But because of some good management practices, some side dressing at planting, starter fertilizer, and it was able to overcome any nutrient tie-up and come along with his best yield. And I've been on a farm that went from really low infiltration rates to that picture there was an 18-inch per hour infiltration rate. And I just shook my head. 18 inches per hour, that's that's more than that night in Hebron when we got 15 inches of rain. No runoff, all that water into the soil profile. That was my aha moment. And I went, we can build systems that can react to extreme weather. And I use a term that Paul Yaza has taught me, active management, active versus passive soil cover. And I believe that's who I heard say it first. And I liken that to these two pictures. The picture on the right is a soybean field left fallow during the winter season. And we see two straight lines running up that hill, up that valley there, that small depression. That's sprayer tracks. And they're going right up there, and water concentrated there and produced a gully during the season and continued to erode through the off season. That can be a really big producer of erosion in eastern Nebraska and across the state, especially on the higher slopes and things like that. In central Nebraska, I've seen that as well. This field here has an active residue, active soil management. You know, the passive residue on the right is a great thing, and that's what no-till provides. It's phenomenal for stopping sheet and rill erosion, but when there's a disturbance like a sprayer track, we can still get that ephemeral gully. And so it's important that we recognize that and can then put this active soil cover on the field. That plant really cares what happens to it. It's struggling to survive. It needs to convey water to its root system and soak it in the ground. It's trying to spread its leaves out above the surface so that it can catch solar radiation and do photosynthesis. So it really is trying to cover the entire soil surface and catch every amount of sunlight it can. So that's active soil management, and we can really use that as a tool to address those gullies. Cover crops in a single year can really mellow out that surface and alleviate surface compaction. We've seen that over and over, that we can address that very surface layer with high intensity root action and the freezing and thawing, like Paul mentioned. So that activity is what leads to soil health. And Jay did a great job of defining the definition of soil health, defining soil health. And I underlined that simple definition, the continued capacity of the soil to function. I like to underline that because that's the same definition as your health. Your continued capacity to function is how healthy you are. Whether you can get out of bed in the morning depends on how healthy you are. Whether you can drive down the road straight depends on how healthy you are. The things you're asking yourself to do, the functions you perform every day, depends on how healthy you are. So it's the concept's not hard to understand when we liken it to a health discussion. And so we're really looking at the fitness of the soil. How fit is it to perform those functions? And Paul talked a lot about the principles of soil health: minimizing disturbance, maximizing soil cover, maximizing biodiversity, and providing that continuous living root. And Jay did as well. And I like to talk about the compounding and cascading results of applying those soil health principles if we can accomplish it through time. And just by having that active residue out there, we can cover the soil and alleviate some immediate erosion concerns. But we're also allowing for a reduction in tillage, increasing biomass with more roots in the soil and higher diversity and that soil cover along with it. But given enough applications of those cover crops and those four principles, we can compound and accumulate the benefits of those, increasing soil organic matter like Jay talked about, and that increased aggregate stability like Dr. Bonko talked about. And then we can continue to spiral up in the benefits. Available water holding capacity increases, infiltration rates increase, more soil organic matter can reduce the amount of nutrients that need to be applied to a system and actually build new topsoil. And we can thereby have less energy inputs and less tillage and more water, and the field conditions improve. And kind of at the end of all of that, then we can finally see crop yields increase. Whoa, that's a lot of other benefits all ahead of a measurable, quantifiable increase in crop yields. And I think that's the take home, is that it takes time. It takes the accumulation of benefits before we see it in such a broad but accurate measurements tool. So we're really working on a huge increment of change before we see a change in that broad measurement of yield. Integrating livestock into this is like greasing the wheels. Livestock inputs, the nutrients and urine that come from the manure, can really allow for a jump start of the biology. It can cycle the residue. We can draw in biodiversity of new insects and organisms, and it can feed the system. Grazing can also be a big detriment if we're creating bare ground. So we have to remember that we're managing for soil health if that's the use of the livestock. Otherwise, it's a forage crop. Otherwise, it's a pasture. Otherwise you're grazing for your number one priority and not managing for soil health. So putting the right target up and saying, I'm going to manage for soil health is really important, because then you're going to make different management decisions in order to accomplish that. The Nebraska NRCS Soil Health Initiative we really began this in 2016, and that resulted in my job opportunity. And I've been the state soil health specialist here in Nebraska since 2016. And in 5 years, we've remained focused on creating partnerships. Some of the most beneficial partnerships we've created are with individual extension agents. Nebraska Extension is a phenomenal program of specialists spread out across the state that are willing and able to engage with their knowledge, with their education, and their resources with farmers on the ground to learn and adjust their system and become productive and profitable. That partnership has allowed us to engage in on-farm research. And the Nebraska On-Farm Research Network is another partnership of specialists all across the state that contribute to an annual results update. They produce case studies of comparisons like this one in the picture on the ground. This is a frost-killed cover crop versus a winter hardy cover crop. And this producer really wanted to see which one provided a good grazing opportunity, which one provided a good soil health improvement, and which one provided any return on crop productivity. So we were measuring quite a few things in that, and we were able to partner with UNL, another partner, UNL Agronomy and Horticulture, and Dr. Andrea Beisch, and a PhD student started to analyze the data and collect more data. And we've really developed this into a phenomenal case study, but most importantly, the partnership with the farmer and his network of farmers and peers. We've hosted field days at these farms, and we've really learned a lot and engaged with the public in this circumstance as well. Gotten a lot of publicity. The farmer, Daryl Obermeyer, is actually going to present on this study at the National Cover Crop Summit. And so I'm really excited about that and the things he's learned about grazing cover crops. So, you know, the synergy that's associated with this can all stem back to those partnerships and the opportunity on the ground. And Gary Lesowing is the extension agent that's engaged here, and he's a phenomenal resource. So I really want to point at those partnerships. We've geographically distributed those opportunities all across the state. And we even have studies out in Keith County and Cheyenne County and Chase County and Custer County and Lincoln County, you know, all the way out west to all the way in the eastern Nebraska. And this farm located in Nemaha County, down in the banana belt, I call it. The opportunity to grow a frost-killed cover crop here is quite phenomenal. So that's an important thing to note, the geographic distribution. We've funded these demonstration projects to provide a local source of information, to validate our soil health management systems locally, and to communicate about soil health and through those potential opportunities. So that's what we've done. We've demonstrated on the field level these management techniques, and I can't iterate that enough. It's field scale, and that means it's real farming practices, and that's the sort of research that has impacted me the most. And I really appreciate Dr. Blanco and Paul Yaza expressing and communicating the things they've learned with farmers and on research farms where they're using real farming practices and field scale research. That's so important to understand the system at a level and understand how a management technique impacts that. So that system comparison through a 5-year expanded crop rotation, that's another really big advantage that we tried to put on the ground with these demonstration farms, is a 5-year project, so that we had time to accumulate the benefits of cover crops and soil health management compared to the growers' system. And so then we randomized and replicated those plots with our partnership with On-Farm Research. We had high-level analysis tools like NDRE, but we also tried to evaluate the system with our NRCS locally adopted soil health protocol. And so Nebraska NRCS has a protocol that we put together on a worksheet, and we're just testing that. We're accumulating the data to see if what we can measure as an agency can help guide a farmer through this process and understand when and if we've made changes and achieved success. So I'm going to talk just a little bit about that here. The On-Farm Research Network, it's one of the foremost on-farm research networks in the country. I can't iterate enough how important this resource is for Nebraska and for Nebraska farmers and ranchers. It's hosted on CropWatch. What a phenomenal platform that's been established there to communicate research and articles and information that's pertinent to Nebraska agriculture. There's a weekly newsletter, periodic newsletter that comes out. If you're not signed up for that, please do. Please sign up for that so that Nebraska Extension can communicate with you. The On-Farm Research Network is hosted there, and the results data is found on a database there, and you can look at any study they've completed in the last 20 years and pull it up, and it's you can search by your county and see what's been accomplished in your county on farm with research partnerships. It's an awesome opportunity. The thing that we're trying to do as an agency is learn with these demonstration farms. And so we're trying to validate this soil health assessment protocol of kind of monitoring and evaluating or assessing the dynamic soil properties. Dynamic soil properties are kind of a new idea, rephrasing kind of the existing data. In a sense, there's inherent soil properties that really can't be changed, like percent sand, silt, and clay. It would take a lot of money and a lot of inputs for you to change the percent sand, silt, or clay of your cropping field. A lot of dump trucks full of silt would have to be added to your soil to actually change the percentage. However, the dynamic soil properties can change rather rapidly, in some circumstances even annually, and those are the ones that we're trying to monitor and measure and assess. And those are the dynamic soil properties. And Jay talked a lot about the soil functions, and I really appreciated that discussion. And I just like to connect these dynamic soil properties to the soil functions that they directly impact. And 90% of what goes on in the soil is mediated by biological activity. So that's the number one reason that biology matters, because 90% of what we're asking the soil to do annually is accomplished by something living there, not by the sand, silt, and clay that exists there. And so then that biological activity is changing the bulk density, the soil color, and the aggregate stability, because it wants to survive. So you see all those holes and those earthworm channels, that's its home. That's the structure that it's built underground, its house. And I liken it to building a brick house. It needs to put some mortar between the bricks so that it doesn't shift or melt or blow away. And it needs a stable home to live in, stability, structure, space, and shelter. So habitat is the biggest and most important soil function that I can point at that really impacts all of the other soil functions. And I like to point at habitat because when was the last time you went out to your crop field and said, wow, look at my wildlife habitat? I don't know if that's ever happened, but I hope that you would begin to understand that under the soil, there's so much life, more life in a teaspoon than you can count. And, you know, I dug this hole on the left here and discovered a 2-inch stripe of this fungus growing in this crop field. You know, we had no idea that was there until we exposed it and explored the soil with a shovel. My biggest assessment tool, best assessment tool, is the tile spade, just like Paul Yaza said. And you know, we've seen things that tell us a story like this radish. When that radish hit the tillage layer, the compaction layer underground, it had a problem, and then it spread out its roots, and we got 4 times our money on that one because it sent down 4 tap roots through that compaction layer. And that's what changes the infiltration rate. The accumulation of those root channels, those pores, and that biological activity. So managing for that habitat, the organisms are what form the wet stable aggregates. They're putting those bricks together with the mortar, their exudates. That goo that's on the outside of an earthworm is its exudate. And it stabilizes the soil around itself. Same thing with roots, same thing with fungus. All of that increases water infiltration, just like Paul explained. And you know, I don't want the crust because it seals off the soil surface and allows for lateral movement of water. And as soon as water begins to move laterally, it stops soaking in and it gains velocity to pick up soil particles and begin the erosion process. So allowing the infiltration rate when the soil's wet is really, really important. And there again, I've noted that 90% of soil function is mediated by soil microbes. The most common practice, just like our problem in Nebraska soils that I've seen, is this tillage-induced root-restrictive compaction layer. I think this is the #1 agronomically important soil resource concern that we have in the nation that's impacting crop production now, is this existing compaction layers. This influences all of the soil functions. Everything we ask the soil to do is limited because of these compaction layers. And it was created by steel, iron, moving through the soil horizontally. And I grew up on a farm and ranch, and I still do some farming. And when I think of disking, I think of moving forward with my tractor. I think of progress. And now I'm beginning to see that it's not the forward momentum that matters, it's the down pressure. Like Paul said, it's the weight of that equipment forcing itself into the soil. And just a tandem disc, offset disc, every disc blade is carrying 250 PSI. That's more than me standing on a postage stamp. That's a lot of pressure. And that forces the space out of that soil right at that point of engagement. And then we're dragging the disc forward and we're creating a smearing. And that smearing creates a disc pan, a plow pan. So these diagrams on the right really describe those layers, and you know, pictures like Paul's of that Western Nebraska soil profile. Those layers are still there, and I can't iterate enough. I took this picture in Thayer County. These cover crop roots grew right through that compaction layer. That taproot grew through the compaction layer. That's the power of cover crops. Those deep taprooted species have a higher rooting pressure tolerance. They can stand more dense soil than our cash crop roots. And when we see cash crop roots growing laterally, we're losing productivity. They're having to search for a way to engage with nutrients and water that's lower in the profile. And that costs energy and time and productivity. So the #1 work that cover crops are doing for us is not above ground biomass. It's the below ground work. And I can't iterate that enough. And so I've pulled up these facts about soil bulk density and the impacts they have on root growth. These are cash crop roots, and it talks about the ideal bulk densities for root growth. And you can see that there's different soil textures here. And so in any of the sandy soils up here at the top, sand is a really dense particle. And so the density of sand is already dense. Sandy soils have a higher bulk density, but it doesn't take very much compaction for them to affect root growth and then completely restrict it. And you can see here in this diagram on the right that tractor tire compaction in most crop fields is increasing it from 1.2 to 1.3 that it might exist naturally to this 1.43. And at the disc layer, we're experiencing bulk densities that are 1.9 grams per cubic centimeter. That's enough to stop any root in any of the soil textures in its track. It just stops root growth, and it has to turn horizontally. I really like to point out that no-tillage systems are only retaining the soil structure that's already there, because leaving the soil alone doesn't do the work to change the soil structure. It's the biological activity that's rebuilding and regenerating soil structure. And so we have to change our mindset to it's something living there that's doing the work. No-tillage systems only don't destroy what you've gained or where you're at today. And that's really, really important. Now, residue management can influence soil health and the soil structure. And so there are, combinations of that really matter. But if we remove the residue and only have a no-till system, we may only stay the same. And that's to be noted in that information. I talked about the compounding effects of applying these principles, and that's what we're gaining by doing these demonstration farms all across the state. I've just taken a snapshot of some that I had the data for ready already in 2020 from our fall sampling season. So this isn't a complete set, but I do like to point out this is the bulk density that we've measured in the 0 to 5 centimeter depth on all of these farms. The only farm I had split out between treatments was this winter hardy versus winter kill, that opening photo that I showed you from Nemaha County. What my point with this is that we did capture the benchmark bulk density, and this is a field average. Before the treatments were applied, the field was at these bulk densities. And you can see that when we started applying cover crops and a soil health management system, the average, the combination of the treatment strip and the cover crop strip had very little impact on the average bulk density in that surface. And it stayed relatively the same. That's important to me because it means that we didn't change the system and increase that surface bulk density. And in a lot of cases, we're gaining, we're improving. A decrease in bulk density is an improvement because there's more air and space, like Paul pointed out. And it got me to thinking, if we're staying the same in the 0 to 5 centimeter depth, are there other properties that are changing that are resultant from a cover crop? And that's what this compounding opportunity to learn on these farms allowed us. And so the 2020 results update case study from Dodge County showed me something. And if you look here in the center, the bulk densities, the check strip was the producer's system of corn, beans, and the soybeans were followed by a rye cover crop. And in 2017 was corn. In 2018, we did not do measurements, but he had soybeans and used a cover crop on the check strip. The intensive one is a corn, bean, wheat system with cover crops after every crop. And in 2019, we went back and measured, and the bulk densities in the center, they equalized. Well, that was a corn or a bean year in 18, followed by a cover crop, and then corn planted into both strips. And it changed to even at 1.06. And then it stayed even in 2020. And I thought, okay, the surface has stayed the same. That's consistent in all the farms. But look what happened to the infiltration rate, inches per hour. We went from 0.015 in the check strip and just under a half an inch per hour in the intensive management strip to a huge change in infiltration. Well, we happened to pound those infiltration rings to 4 inches. And that 4-inch depth, that bolt density interacts with a compaction layer that's found in this field. From 2 to 4 inches, there's a blocky layer that's compacted and has a higher bulk density. And in this 3 years of crop system changes, we've addressed some of that compaction issue and allowed a higher infiltration rate, quantifiable from the farmer's perspective, because part of the field used to drown out and part of the field on the slopes used to drought out. And now neither one is happening. He had far less ponding and didn't drought out on the hill slope this year. And look what happened to the crop yields. The corn yields actually separated, probably related to water that was available to them. It's a rain-fed system, and all things held equal, the statistical confidence was that the treatment had an effect on crop yield. And so that's a phenomenal opportunity to learn with these case studies. All these case studies are only available because of our partnership with On-Farm Research and UNL's agronomy department and horticulture department. I really appreciate their partnership. They just hosted their On-Farm Research results update meetings on the 25th and 26th. And that really was a phenomenal opportunity. So they also host our soil health initiative. I really want to move into this part of my presentation quickly and talk about the new soil health resource concerns and the conservation practices that are available through participation through EQIP in Nebraska. The new compaction is a new concern. Organic matter depletion is a new concern. Soil organism habitat loss or degradation, and aggregate instability. Those blue ones are new, and those are really important in Nebraska. And so we now have a crop infield soil health assessment worksheet, nationally adopted. It identifies those resource concerns through a decision support tree, and we can clearly identify from these field indicators, yes, you have a soil organism habitat degradation problem. And so that's a really amazing opportunity. There's new conservation practices that are available to support soil health management and activities with our partnership with farmers. And I really am really excited about the soil testing activity, number 216. It's kind of a misnomer because it's not just a chemical analysis like a standard soil test. It's a suite of tests for benchmarking soil health and the properties of the soil at that point in time. So that's a really phenomenal opportunity. I'm going to talk more about that. Soil carbon amendments, that's the application of compost or carbon amendments like coal ash or biochar or wood chips. I'm going to talk more about that too. The soil sampling practice is really about quantitatively and analyzing the soil physical, chemical, and biological properties. And that's the key. It's all three of those soil properties that we're looking at in that suite of tests. We have this tech note that documents a consistent method and validated research that supports the use of these measurements in these ways. So there's an aggregate stability procedure, and soil organic carbon, active carbon, microbial activity, and bioavailable nitrogen are all aspects of that suite of soil tests. And I'm ready to dive in, right? Well, actually, there's more to it. The conservation planner and the producer identified that compaction and erosion issue, and they may choose to adopt cover crops and a no-till management system, but there's still a lot of decisions that need to be made and supported. And that's where the 216 practice can really come into the mix, is we can have some evidence of what needs to be addressed and then start to prescriptively manage that field to track change and success and really improve soil health. And I'm really excited about the new national tech note that guides the analysis of the results. So when we identify these resource concerns, we can walk through the short-term and long-term management practices that we can use, and we can identify the practices that will help address those resource concerns. And we can work with farmers right now in conservation planning all across the state. The soil carbon amendment, the 808 practice, is brand new as well. It's an interim practice, so we're really monitoring how we use it and the opportunities that we are putting out there for 2021. One of those is a partnership in western Nebraska with a coal ash opportunity to apply coal ash. And so I'm really excited about monitoring that progress and the application of this practice in that way. But it also includes opportunities to apply compost. That composted manure concept, but it has to be mature compost. And so we're going to keep composting that until it hits some thresholds of maturity. And then biochar is another opportunity, and woody materials like wood chips. Biochar is a really interesting product. It's a stable form of carbon that's amazing soil organism habitat. It's really the space and shelter already packaged up for those microorganisms to live in. And it's an interesting kind of horizontal topic in soil health management. So it's something to keep your eyes on. The biggest thing that I like to point out is, okay, we've adopted these practices. Now 3 to 5 years down the road, what now? Well, we can repeat those soil sampling, that soil testing, and evaluate the benefits and outcomes, make plan adjustments, share information, and really support education, but measure success. We now have a way to quantifiably say, hey, we changed this factor in your soil. So for more information on this stuff, I'd really ask you to engage your local field office, begin the conservation planning process with those subject matter experts, and help them walk through an entire conservation plan of good farming practices that all support soil health management. These are some other tools at your disposal. The Field Office Tech Guide and the Web Soil Survey can get you started. I really appreciate the opportunity to be here and talk today, and I'd leave you with this. How can you improve Nebraska's soil health? I'd say dig in and learn a lot and begin to address that legacy compaction issue that is probably found in your crop field. So thanks a lot, Bajesh. I'll open it up for your comments and questions, and I'll stop sharing.
Yeah, thank you. Thank you very much, Aaron. While we do the post presentations poll, Aaron, maybe you can address one question that we have here in the chat. What about compaction when using a roller crimped to terminate cover crop? Should we avoid that compaction?
So roller crimping is an interesting cover crop termination technique that involves a really mature cover crop and then a roller with sharp blades on it that actually bend the cover crop over and essentially can chop it off to terminate that cover crop. The use of a roller crimper is really only successful when the cover crop has reached a maturity at which that bending snaps the stem and then causes, its death, basically. And roller crimping is not widely adopted, but it is a technique. It takes special management considerations. You're going to have to let that cover crop grow for a long, long time. And the reason I'm pointing that out is there's going to be a lot of biomass. And biomass, that soil residue, that surface cover, can support a lot of weight. It can support tractor tires and disperse that weight over the soil surface. It's like armor. And Paul Yaza talks about soil armor. And it's a strong man holding up that weight. And so the surface residue can alleviate any of the sort of compaction that might occur from a roller crimper. Now, rock rollers, and there's all sorts of rollers that are used in some circumstances to level a field and flatten it, those things can cause serious compaction issues. And I would say anytime we can disturb the soil less or compact it less, then we're going to be further ahead.